Today we're going to talk about the concept of cognitive load and code smells. My name is Felienne Hermans and I'm the author of The Programmer's Brain. I think you're going to enjoy this live stream most if you either watched my previous live stream that's available also on Manning's YouTube channel, or you've already read a few chapters of my book, because in this video we're going to really dive deeper into some of the concepts that have been covered before. So if you've never seen or read anything, then maybe the best thing you can do is first to check out other content, because this might otherwise be a little bit too detailed and too deep. So we talked about cognitive load, which is the idea of the busyness of your brain, like how hard is your brain working on a problem. And cognitive load, like how hard your brain is working, can be divided into three different types, three different subtypes of cognitive loads that are very, very relevant once we start talking about code smells. And the first type of cognitive load is called intrinsic load. An intrinsic cognitive load is cognitive load that is just related to the problem. For example, here you see in this calculation, if you have to calculate the length of this side of the triangle, then you just need to be able to add a square and b squared together, and then you get c squared. You have to take the root of this. So any problem has, as we would call this in programming, like an intrinsic, an inherent complexity. And inherent complexity creates intrinsic load. There's nothing really we can do about that. However, the way a certain problem is phrased can give extra cognitive load. And this extra cognitive load, we call this extraneous cognitive load. So if you phrase your problem in a certain way, like rather than putting the 6 and the 8 on the triangle, you put an A and a B on the triangle, and then you put the values of the A and B somewhere else. This is the same problem, right? I haven't changed anything about the problem, but the phrasing has made it slightly more difficult to now do the calculation, because mentally you have to move the 6 and move the 8. This type of load is called extraneous load. Additional, accidental complexity is what you might say in programming, where you're adding complexity that isn't necessarily needed. Then there's a third type of cognitive load as well. The third type of cognitive load is called germane load. And germane load is the effort that your brain needs to actually store stuff into your long-term memory. So your brain shouldn't be all too full, because if your brain is entirely filled with intrinsic and extraneous cognitive load, then you will be able to do something. You will be able to process the programs, but you will not be able to remember the program. So these three types of cognitive load play a large role if we start to examine code smells. So that was just a brief recap of cognitive load. And as I said, if this was a little bit quick because you haven't heard about those concepts before, then my book or my previous live stream are great sources to go in more depth into these concepts. So now let's look at code smells. Probably you're somewhat familiar with the concept of code smells, because it's a very well-known and sort of an old idea already in programming land. The idea of code smells was first coined in Martin Fowler's book Refactoring, Improving the Design of Existing Code. And this book both coins the idea of code smells and also the idea of refactorings, which are ways to relieve code smells. So code smells and refactoring very much go hand in hand, and they were introduced together in Fowler's book. So just to give you a sense of what is code smells, if you've never heard of them, code smells are part of a program that are not ideally structured. So it isn't necessarily an error or a bug, but it's just that your code is not great, right? This is why it's called code smells. It's like, something's off here. For example, a long method. Now you have a long method, and it might very well be that this method is perfect, that there's no error, but you know that if you have a method that's like 100 lines long, it's just harder to process than if you have a method that's maybe 5 lines long or shorter even. Maybe a one-line method can be really quick to grasp what is there. Long parameter lists can also be seen as a code smell, where rather than a function with parameters x and y, there's this super long, we have some examples later on in the slide, a function with a super long list of like 11 or 12 parameters. And then you have to remember all the parameters. And again, it could be the case that this function is working perfectly. There's nothing necessarily wrong with it. But having many parameters is also somewhat of a smell. And of course, as I said, smells and refactorings go hand in hand. So if you have a function that has a very, very long parameter list, maybe there are actually two functions, right? Maybe this function could be split and then half the parameters are used in one part and the other half is used in another part. So smells very often lead to a potential improvement. There are many other smells. Actually, I think the list of Fowler is like 23 different code smells. I'm not going to go over them, I want to give you a little bit more of a sense of what we're going to talk about today. So other examples exist at the class level. So for example, a class can have many methods and fields, so many that it's not really clear what the thing is doing anymore. And this happens sometimes if you have something like a utilities class, rather than thinking, oh, this method that I want to create, what object does this go with best? Like I've certainly made the mistake of like, oh, let's just put this in the utilities class and this and this. And then at one point, this is like this very, very big blob of functionality where some parts might actually rather live in a different class where they belong better. The opposite of a large class is a lazy class. So you can also have a class that's just a little bit of data, maybe one or two functions, that also doesn't really help readability, because then of course your code base gets divided also over different files, because classes often live in their own files. So if you have a little bit of functionality in a class, that's also a sign that maybe something could be restructured a bit. Other smells that are commonly occurring in code are the duplicated code smell. This is also called code cloning, where you have slightly different versions of the same code, or sometimes it can also be exactly the same code in different places in the code base. And this is an issue because if you want to make a change to one of the clones, then maybe you also want to make the same change to other clones, and you might forget like where the clone code is located. So lots of duplication in a code base is also a sign that something might be off. The final code smell I want to talk about today in this video is message chaining. And message chaining is a code smell in which one function calls another function, and that function then calls another function, and that calls another function. And very often it isn't just calling functions, but it's also passing a blob of data. So I'm calling a function with a parameter, and then the next function is also taking in this parameter, maybe adding more, and then like a ball, like sending the ball to the next person, and then the data hops through the entire code base. And this might make debugging really hard. Like I've stepped through programs with a debugger where you go into a function like, okay, this is where the error occurs. Let's see what happens. And then it goes into another function, and it takes a very, very long time until you really have pinpointed where an error, for example, is located, or where a certain operation is being called. So what you see here firstly is that the code smells in Fowler's library, in Fowler's catalog, have very, very different scopes. And this is actually a new analysis that we do in my book that Fowler didn't really do. So Fowler just had this list of code smells, and it's been a great resource, and many people have really benefited from it greatly, including myself. Like I've done much work building on the idea of code smells. But the code smells in the catalog are very, very different in scope, and we zoom into this a lot in chapter 9 of the book. Some code smells, for example, in this small set of the catalog, like long method and long parameter list, are method level smells. So they only occur within a method. I can look at a method and I can decide whether that's a long method or a short method, like if I've set what I think is long or short. But this is very much the method scope. There's also smells in Fowler's repository that are at the class level. So a large class is a class level smell. And then there's code smells, for example, like duplicated code and message chain, that exist at the code base level. Like I cannot look at one method and decide, is this duplicated code? Because the other clone, like the duplication of this method, might live in a different class in the same code base. And the reason why this is important, well, firstly, it can be important for detection reasons, right? Like you want to understand, is this code base smelly? You have to understand what is the scope I need to examine. But from the perspective of what we talk about in this video and in the book as well, from a cognitive perspective, these different scopes of code smells also really do different things to your brain. And that's what we're going to zoom into a little bit more in this talk. So firstly, let's examine in general. Like later in the video, we'll talk about specific examples of code smells and why they are troublesome from a cognitive perspective. But let's first look at code smells in general. Like why are code smells problematic in general? And to answer that question, we have to go back to those 3 different types of cognitive load. What code smells do is they increase extraneous load. Right, so the lowest level, the intrinsic load still stays the same. If you have a function that calculates, I don't know, it calculates the square or something, it doesn't really matter if you do this in 1 line or if you do this in 1,000 lines for the inherent cognitive load, for the complexity of the problem itself. It doesn't really matter how you write it. But the way you phrase it is very much going to increase potentially the extraneous cognitive load, the extra effort that your brain has to put in to understand the code. So extraneous load is the part of cognitive load where code smells create issues. So diving a little bit deeper in different smells and different cognitive issues, because not all smells are smelly for the same cognitive reasons. And for that, also, we have to do a little recap of stuff that we talked about in a previous video and stuff that I talked about earlier in the book is what exactly happens in your brain. What happens in your brain if you process like anything, specifically if you process code? You might remember from the previous video that there are actually 3 different types of memory systems involved. Firstly, if code comes into your brain, like through your eyes and your senses, code firstly comes into the short-term memory. So you read a bit of code and first it's only remembered in the short-term memory. Then thinking about code, processing the code, actually happens in the working memory. That's the box in the middle at the lower end. So you have working memory where the code is being processed. While you are thinking about code, your long-term memory also sends information to your working memory. So you're not, of course, reading a C program like you've never seen any C or any program before. Your long-term memory says, hey, here's the semantics of an if statement, and this is what curly brackets mean, and this is what the meaning of that variable name is. So your long-term memory is sort of shooting off information to your working memory, like, hey, here's some relevant things that you might also want to consider while thinking about code. This is more or less what happens in your brain. And we will dive now into what code smells sort of mess up in the arrows that are there in your brain when you're looking at code. If we have a smell like a long parameter list, so we have a method that rather than taking in 2 or 3 parameters, takes in 12 parameters or something. So here's an example. Maybe you have seen something like this before. This is like a constructor type of function that takes in lots of data and then puts all the arguments on an object. So you see that this list of parameters is very, very long. So if you want to properly call this method, you look at the definition, like, oh, okay, what goes in? Country, state, city, place, date, average, max, min, pollutant. Okay, this all goes in. So if you want to call this method, you looked at the definition and then you go to the location of your code where you want to actually create an instance of this class, you have to remember, you have to remember everything that was there. And of course, in some situations, IDEs can help you a bit there by also looking at the code and giving you a list of what is there, but not always and not always enough. So a long parameter list creates an issue in your short-term memory. It isn't necessarily that this code is hard to process. It isn't necessarily that your long-term memory doesn't know what's going on. It's not hard to understand, right? It's not hard to remember what's going on. The thing that is hard is remembering everything. And I'm sure you've been in this situation where you've looked at a certain API definition or a definition of a function. You're like, okay, so looking at the API reference, okay, let's go. So what is there? Okay, this in this order. And then you hop over to your actual code where you're going to do the API call. And you're like, okay. Oh, I forgot. What was it again? You have to go back to the definition in the code. You have to go back to your API reference. Like, oh yeah, this was the order. And that sometimes goes like 1 or 2 or 3 times, which is just like time and energy wasted. So that is very much a short-term memory issue. And that's why you don't want to create calls. You don't want to create functions with very long parameter lists, because then you're putting the burden of remembering everything and remembering everything in the right order on the caller of the method. So long parameter list is troublesome because it overloads the short-term memory. We've talked about this in a previous video as well, people can only remember between like 5 and 9 things at the same time. So if your parameter list is longer than, let's say, 7, like in the middle of between 5 and 9, more or less 7 is what people can remember. So if you put more in a parameter list, people will not be able to remember everything in one go, causing this back and forth behavior, looking up the definition before they can continue with calling the function.